Hi everyone, today's lesson is on solving trigonometric equations. So the first thing we're going to do is start off with a little warm-up. And for a warm-up, you're going to need to know how to draw the graphs of the sine, cosine, and tangent inverses. So for sine, for arc sine, this graph will come up and do this. You're going to need to state the domain and the range for both. So domain and range. So for the domain, we have -1 to 1. For our range, we have negative pi over 2 to pi over 2. So negative pi over 2 to pi over 2. For cosine inverse, this one is going to sit on top. And so this is our cosine. For our domain, left to right, we have -1 to 1. And for our range, it goes 0 to pi. So that's going to be inclusive of 0 to pi. And for arc tangent, tangent is going to do this and like this and go on. And so for my domain, I have -infinity to infinity, and my range from here to here. Now remember, this is tangent, and these are asymptotes from here like this. And so for my range, it's going to be parenthesis negative pi over 2 to pi over 2. So negative pi over 2 to pi over 2. So in evaluating these expressions, these are our restricted domains. We have an area where we can go that we can't get out of. So for this case, this is saying, where is cosine root 2 over 2? So remember, cosine can be from 0 to pi. So from here to here. For it being positive, root 2 over 2, right? First quadrant, root 2 over 2, that's going to be a 45-degree reference. So cosine is going to be 45 degrees, or pi over 4. Okay? For tangent, arc tangent, where's tangent? -1. So for this one, we're looking at tangent. Now remember, tangent is negative pi over 2 to pi over 2. So for tangent, you've got this space in here. So tangent is negative in this quadrant, not over here. It's got to be within this restricted area. So -1, where is tangent? -1. So that's also going to be a 45-degree angle. However, it's going to be down 45, so it'll be negative 45 degrees, or negative pi over 4. For this one right here, we've got, where is cosine? Or what is cosine? Notice this is a cosine without an arc, without an inverse. So that's a what? That's asking for a numeric value, where this is asking for me for an angle. Where's my angle where tangent is -1? Where's my angle where cosine is this? So if this right here being arc cosine, that's the same thing as saying that, I need to find what cosine of 5 pi over 4 is. So I'm going to draw my graph, and I'm going to say 5 pi over 4 is 1 and a fourth. So it's 1 plus a fourth. And a fourth being a 45-degree reference, right? That's a -1, -1. Where am I? What's this value right here? So cosine at 45 degrees, all students take calculus, tangent's positive here, which means cosine's negative. So that's going to be -1 over root 2, or negative root 2 over 2. Now, the rest of this, see this right now? We figured out what cosine of 5 pi over 4 is, which is negative root 2 over 2. Now this is asking me, where am I? However, I can only be from 0 to 2 pi. That's my restricted area. So where am I where cosine is negative? It's going to be have to be in the second quadrant. And where I'm at is here, where there's a 45-degree reference, right? So from here to here is going to be 135 degrees. Or you could say 3 pi over 4. Okay, for this one, it's saying, where is sine? So that's asking me for an angle. Again, Anytime it's an inverse, it's asking me for an angle. Anytime it's not, it's asking me for a numeric value. So this is asking me for an angle. So where is sine negative root 3 over 2? But because, see this negative? This is my restricted area. So sine and tangent share that same area where it's restricted. So you have negative root 3, so it's going to be down here. Sine is opposite over hypotenuse. So where we are is at negative 60 degrees. Or you can say it's pi over 3, negative. For this next problem, this is saying, where is tangent after you find sine of pi? So we're going to find sine of pi first. So in finding sine of pi is over here. There's sine, pi, negative 1, 0. Sine is 0. So we have tangent. Where is tangent? 0. And when asking that, when you're thinking about where is tangent 0, well, tangent of 0 is 0. And that happens in between this area for our restricted domain. For this problem right here, this is saying, where is sine 1 over 7? So that's not a special right triangle, but we do know that sine has this restricted domain here. We also know that sine this is positive, so it's going to be in the first quadrant. And sine is opposite over hypotenuse, which is 7. So this is asking me, well, let's find this other side here first. That's 49. Using Pythagorean theorem, this is going to be the square root of 48, 49 minus 1. Square root of 48 is actually 16 times root 3, which is 4 root 3, okay? Once we found where we're right here, then we can find what sine or what cosine is. Cosine is adjacent over hypotenuse, so that's answer is going to be adjacent for root 3 over my hypotenuse, which is 7. So we're getting started on solving trigonometric equations. For this value, I want to find all my solutions, no restrictions. I want to find every value that for x. So the first thing, our objective for this problem is to solve for x. We're going to get x by itself. We're going to move this cosine to the other side of the equation. And for doing that, we're going to get arc cosine of 1/2. And this is asking me, where am I? What angle? Anytime you see an arc, that's asking you what the angle is. Where are you? On the unit circle, where are you? And so for this problem, I want to know, where is cosine 1/2? So in doing if you remember this mnemonic, all students take calculus. We know that cosine is positive in this quadrant here and in this quadrant here. It being 1/2 adjacent over hypotenuse, this being root 3, where are we? This means we are at a 60-degree reference angle. So we know that we're at a 60-degree reference angle. So x is equal to 60 degrees, or you could say pi over 3. And we are not going to go, at this point, we're going to go find all the positive values first, which is all the way around here, which is going to be 300 degrees. Or you can also say 1 and what is that? 2/3 pi. So what's 1 and 2/3 pi? That's going to be 5/3 pi. So we have 5/3 pi. We also had pi over 3. And so what I want to talk to you about is this. When we're doing these problems, right, and I want to find all the values, every single solution, that means I'm going to find this value from here to here, and then again after 360 degrees, and then again, and then minus. So what this means is, if I want to find all solutions, this is going to be plus or minus 360 degrees n, or plus or minus 360 degrees n. And similarly, if I am in radians, okay, you're going to say plus or minus 2 pi n, or plus or minus 2 pi n. And it's possible that on a test, we might ask you, what's the next value? Besides, you have pi over 3, 5 pi over 3. What's the very next value? Well, you would take pi over 3 and add 2 pi n, and then get that answer. Okay, next problem, we're going to find all solutions again. So we're going to get sine over to the other side. So we have x equals arc sine of negative root 2 over 2. All solutions, no restrictions. And so in doing this problem, where is sine negative root 2 over 2? Well, I'm thinking sine being all students take calculus. Here again, this is a negative value. So we're not looking here or here. We are looking in this quadrant here, which is the third quadrant, for sine, which is negative 1, root 2, which is negative root 2 over 2, this being a 45-degree reference. And therefore, that value is going to be 1 and a fourth. So 1 and 1/4 is 5/4 pi. So we know we have x equals 5/4 pi. There's one of my answers. And then the other answer is going to be in this quadrant here. Again, okay, same values, except for it's 1 and 3/4 pi. So 1 and 3/4 pi is 7/4 pi. And if I want all the solutions, I'm going to either add or subtract 2 pi n. Add or subtract 2 pi n. And remember, these values right here are for all solutions. And because it's sine, and the previous problem was cosine, this is a period is 2 pi. So I'm going to go around again at 2 pi. But keep in mind for tangent, for finding all solutions, you only are adding or subtracting pi n, because tangent's period is pi. Next problem says solving trig equations continued. You've got to still solve for x, but for this problem, I want to find all solutions from 0 to 2 pi, not including 2 pi. And if you do this in degrees, you're going to go from 0 degrees to 360 degrees, but not including 360 degrees. So to solve this, the first thing I would do is divide by 2. And so I'm going to get sine squared of x equals 1/2. And then I'm going to square root both sides. And in square rooting both sides, I'm going to get sine of x equals, and in this, remember, that's the same thing as saying the square root of 1 over the square root of 2, right? Which is equal to 1 over root 2, which is equal to root 2 over 2, which you know is a 45-degree reference. Now, that being said, you're taking a square root, which is going to give you a plus or minus value of root 2 over 2. So that could be a little bit tricky, because now you're not only solving for positive root 2 over 2, but also negative. So this is what we're going to do. Move sine over to the other side, and I have x equals arc sine of positive root 2 over 2, and also x equals arc sine of negative root 2 over 2. And so when I'm working these problems, I need to do this twice. So think about it like this. For this one, this is asking me what angle. See the arc sine? What angle? Where am I when sine is positive root 2 over 2? So we've got all students take calculus. So, right? And I'm positive in this quadrant and in this quadrant, not in those. Okay? So where am I? From here to here, I'm at 45 degrees, or pi over 4. From here to here, I am also in 45-degree reference, but this is going to be 3/4 pi. Okay? This one, however, is asking me where is it negative. But I need you to be really careful in that you don't go down. Right? I know you want to go down because you're like, well, this is a restriction, but these are no restriction. This is all solutions. That's only between 0 and 2 pi. And if I went down, that would give me a negative value. And a negative value is not within my solutions for 0 to 2 pi. So this would not be a solution because I can't have a negative value. That'd be less than 0. So be careful for that. For this one, where is sine? Negative root 2 over 2. So it's going to be here at 1 and 1/4. So 1 and 1/4 is x equals 5 pi over 4. And then from here, 1 and 3/4. So 1 and 3/4 is x equals 7 pi over 4. So for this problem, I'm done. I'm not going to add or subtract 2 pi n because, again, my restricted area here is from 0 to 2 pi and not including 2 pi. And so this is not going to happen here because it's outside of my restrictions here, which goes from 0 to 2 pi. So when writing my answer, I would include all those numbers, pi over 4, comma, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay? Same question, same restrictions, 2 cosine x equals -1. I want all the values between 0 and 2 pi. So for this one, I'm going to divide by 2 first. I get cosine of x is equal to -1/2. I'm going to move my cosine to the other side. I get x equals arc cosine of -1/2. And now I'm asking you, where is cosine -1/2? I want all the values from 0 to 2 pi. So what I'm thinking is that this is negative right here. And so therefore, I'm not going to think about quadrants where cosine is positive because this value is negative. And so the values, now I'm going to say, okay, well, here it is in the second quadrant. Now cosine is adjacent over hypotenuse, right? For our little special right triangles. Across from the root 3 is our 60 degrees. 60 goes into 180 3 times. This is a 2 pi over 3. So x is equal to 2 pi over 3. In addition to that, we're also here, okay? And being down here is another 1 pi plus a third. So 1 plus 1/3 is 4/3. So I'm also at 4 pi over 3. And because I don't have, it's not a quadratic, it's not a quadratic. I'm not taking the square root or anything. I don't have 2 answers for each one. It's just that one. Or excuse me, just those 2 answers. So for this one, I want to find all solutions. Okay, so I don't have a 0 to 2 pi restriction. It's just every solution. So when I'm done, I am going to add plus or minus 2 pi n. So that I'm going to remember that until I'm all done. So I'm going to look at this. Now this is not, I'm not trying to verify this identity. I am not trying to prove that the left side equals the right side. I'm trying to solve for x. Okay, that's what I'm trying to do. So that means that I need all of my values on one side. So I'm going to move this over to the other side first. And I'm going to get sine, let me rewrite that. And I'm going to get sine of 2x plus sine of x is equal to 0. Now, I don't want you to think that I can factor out a sine because you cannot. I mean, if I had this sine squared of x plus sine of x, right? Then I can take out a sine of x, okay? And then I'd still have a sine of x left plus 1. That is not the same thing as this. If you notice right here, that's a double angle, okay? That is not this. And so you can't do this for this problem. For this, you need to take sine of 2x and change that into 2 sine x, cosine x, which is our double angle formula, plus sine of x, n equals 0. Now, what I can do is I can factor out a sine. I have sine in this and in this. So I'm going to factor out a sine of x. And what's left is 2 cosine of x plus 1 equals 0. And now that I'm multiplying, I can split these up. And I'm going to get sine of x is equal to 0. And 2 cosine of x plus 1 equals 0. 2 cosine of x equals -1. Cosine of x is -1/2. And x is equal to arc cosine of -1/2. And this one is x equals arc sine of 0. Okay, so now you notice I have 2 different equations. The one on the left is asking me where is sine equal to 0? And see, remember what our question was to find every single solution. Where is sine equal to 0? That's what I want to know. If I were to drawing a sine graph, there is it. 0 here, 0 here, 0 here, right? Well, it's at 0 it's at pi, it's at 2 pi. But if I go 0 plus 2 pi, I'm going to get 2 pi again. So I can say x equal to 0 degrees, and I can say x is equal to pi. Oh, excuse me. I should have said 0 I should have said just 0 instead of 0 degrees. If I'm going to stick with either degrees or radians. You don't have to do both. So I'm going to stick with 0 radians. Now, because I'm trying to find all solutions, this is going to be plus or minus 2 pi n. This is going to be plus or minus 2 pi n. Okay. This one right here is asking me, where is cosine -1? Well, I'm looking at my graph and I could say, -1/2. And I could look at my graph and I'm thinking, okay, here's my circle. All students take calculus. This is a negative value. See that right there? That means that cosine is positive here. So I'm not looking here and I'm not looking here because those are the two quadrants where cosine's positive. So I need to know, where is cosine -1/2? So it's got to have to be in this quadrant. And remember, cosine is adjacent over hypotenuse. Again, that means this is √3, which is a 60-degree angle, which means this is 2/3 pi. So now I have x equals 2 pi over 3, and x equals, because I now have to go down here and also find out where I am. This is going to be, if this is 2 pi over 3, then this is going to be 1 pi plus 2 pi over 3. So 1 plus 1/3, 1 plus 1/3 is going to be 4/3 pi. And so remember, I want all the values forever and ever and ever. See, find all solutions. So we're going to go plus or minus 2 pi n, plus or minus 2 pi n. And so every one of these is an answer. Okay, these are all my solutions here. And they all work. And then they're all going to give me the solutions forever and ever. Keep going. For this problem, I'm trying to find all the solutions. And again, so my answer will be plus or minus 2 pi n, unless, right, it's a tangent, which it's not. So I don't have to worry about that. This looks like it's a quadratic, and I'm going to try to factor that. Okay, equals 0. And in doing that, it's going to be 2 times cosine of x times cosine of x. That's going to give me 2 cosine of x. I notice that my signs are positive here, but negative. So that means that both of these are negative times a negative is going to give me a positive. I'm also trying to sum. My sum is trying to be -5. So that means that I need a 2 here because I'm going to go 2 times 2, which is -4, and then a 1 here because that'll be -1. So -4, -1 is -5. I'm going to split this up, and I'm going to go, well, cosine of x minus 2 equals 0. Cosine of x equals 2. X equals arc cosine of 2. Remember, that's like 2 over 1, right? This one is going to be 2 cosine of x minus 1 equals 0. 2 cosine of x equals 1. Cosine of x is equal to 1/2. And x is going to equal arc cosine of 1/2. And so what this means is that I'm trying to find answers where cosine is 1/2 and 2. But does anybody see a problem with this one right here? Okay. When you're looking at that and you're asking yourself, where's cosine 2? Let me draw my graph. Remember our graph of cosine? Cosine starts high, ends high. And this was 1 to -1, right? Where is cosine going to be 2, which is up here? Well, we're not doing any kind of shifting or anything like that. This is just our sinusoidal graph. It is never going to be 2. Okay, so this is a no solution here. There's no solution for this value. There is nowhere where cosine is going to be 2. Also, keep in mind that I could have drawn, like, let's say, a circle, and this is positive. And if I were drawing this, right, and I was drawing cosine, which is adjacent over hypotenuse, do you see that? Well, you would also hopefully have found that my hypotenuse can't be smaller than the length of one of my sides, the legs, okay? So this one doesn't work. But let's try to figure out where cosine is 1/2. So again, let's look at this, our circle. We've got, it's a positive. All students take calculus. Cosine is positive in these two quadrants here. So therefore, these are out. So we're just looking at the first quadrant, okay? Cosine being adjacent over hypotenuse, another root 3, 60 degrees. That's a third, pi over 3. So we know that it's going to be pi over 3 plus or minus 2 pi n, because they want to know forever and ever. But in addition to that, again, for this, we're going to go all the way around down here, and we're going to get a 60-degree reference angle. But remember, from here all the way around is 300 degrees. Or if you're counting in radians, that's pi over 3, right? This is pi over 3. So you can think of it either as being 2 pi minus pi over 3, right? You could think of it like that. Or you can think of it as 1 and 2/3. So what's 1 and 2/3 pi? So that's going to be 5/3 pi. So x equals 5 pi over 3 plus or minus 2 pi n. And so these two values here are my solutions because this one didn't work. So the next problem says solve the equations. Well, this implies that there's more than one equation. So solve the equation. We have secant squared of x minus 2 tangent squared of x equals 1. For this problem right here, I'm going to use one of my Pythagorean identities that says tangent squared of x plus 1 is equal to secant squared of x. And I'm going to do that because I can see that I can replace this with this. You see that? And so I'm going to get tangent squared of x plus 1 minus 2 tangent squared of x is equal to 0. Well, one of these minus 2 of those, I feel like I missed a 1. Oh, I forgot my 1. Anyway, one of these right here minus 2 of these right here is going to give me minus 1, minus tangent squared of x. So I have 1 minus tangent squared of x is equal to 0. And I'm going to move my tangent over to the other side. So I'm going to have tangent squared of x, moving this over to the other side is positive tangent squared of x is equal to 1. I'm going to square root both sides, and I'm going to get tangent of x is equal to plus or minus 1, which means that I need to do this twice. I'm going to get tangent of x is equal to 1, and tangent of x is equal to negative 1, which then is going to give me x equals arctangent of 1, and x equals arctangent of negative 1. So I want to know, where is tangent 1? So we know that tangent is positive because that's positive, in the first and the third quadrant. So that means that it, being at 45-degree reference, right? You've got 1, 1, square root of 2, 1, 1, square root of 2. Tangent is opposite over adjacent. So where is tangent 1? I'm at 45 degrees, or at pi over 4. I'm also in this quadrant down here at 1 and a fourth, at 1 plus 1/4, which makes 5/4 pi. So x equals 5/4 pi. Please keep in mind that this is tangent, and tangent's period is not 2 pi. So when I add or subtract 2 pi n, that's not accurate. You're going to add or subtract pi n plus or minus pi n. Okay, so far I got 2 answers. Now I'm going to get the other 2 answers by finding out where is tangent negative 1. So tangent is negative 1, then not in this quadrant, but in this quadrant here, so opposite over adjacent, and in this quadrant down here. So this is going to be 3 pi over 4, so x equals 3 pi over a 4, meaning I'm a fourth short of being a whole. So plus or minus pi n. And then also x equals, x equals all the way over here. So that's 1 and 3/4. So 1 and 3/4 is 7/4. So 7 pi over 4 plus or minus pi n. So I just realized something, that I was solving for all solutions. So instead of solving from 0 to 2 pi, this right here is I'm solving for all solutions. Okay, so what I did was, because I was trying to prove a point with the pi n instead of the 2 pi n. But that being said, if you are only solving from 0 to 2 pi, then your answer would be x equals, and you would write it just like this. Pi over 4, 5 pi over 4, you can write it. Oh, and this is not in correct order, because I could say 3 pi over 4 is actually next. So let me fix that. So pi over 4, comma, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, so if I'm only solving from 0 to 2 pi and inclusive, okay, without counting 2 pi, then these would be my answers right here, all of these. But if I'm solving for all solutions, then I would have the plus pi n. And that was the point I was trying to make, but anyway. So the next problem, and these ones right here, this is actually supposed to be a curve like that. Okay. I am going to solve for x for this problem. I am going to change this, because it's a double angle, to 2 sine x cosine of x. I see that I have sine of x plus, so I'm going to go plus sine of x plus 2 cosine of x plus 1 is equal to 0. So what I notice about this problem is I actually have 4 terms, and I don't usually have 4 terms. And what comes to mind for me is when I have 4 terms, I like to think of factoring by grouping. And so I'm going to group the first 2 terms here, this term, and I'm going to group these 2 terms and see if I can get something to come out of that. In grouping the first 2 terms, I notice that I've got a sign common between. So I'm going to factor out a sine of x. In doing that, I'm going to be left with 2 cosine of x, and then factoring out the sine x from that, I get plus 1, which is a good thing, because look what I have here, 2 cosine of x plus 1. And if you remember, by factoring by grouping, your next step is to actually factor out the 2 cosine x plus 1. So 2 cosine of x plus 1, and then what's left is just this and this. So sine of x plus 1 equals 0. And for this, since we're multiplying, I am going to split this up. I get 2 cosine of x plus 1 equals 0, and I get sine of x plus 1 is equal to 0. This left side will be 2 cosine of x is equal to negative 1. I'm going to divide by 2. I'm going to get it cosine of x is equal to negative 1/2. X is equal to arc cosine of negative 1/2. And that's asking me, where is cosine negative 1/2? This one is saying sine of x is equal to negative 1. X is equal to, move the sign over, arc sine of negative 1. And so I've got 2 questions. Where is sine negative 1, and where is cosine negative 1/2? So for cosine, right, you're thinking, well, where is it negative 1/2? Well, cosine is negative, not here and not here. So it's negative here. So where I am here, being adjacent over hypotenuse, is again at a 60-degree reference, right? 2/3. So we are at 2 pi over 3. And then also down here, which is at 1 and 1/3. So 1 and 1/3, which is 4/3 pi. Okay. And these equal x. And then here, where is sine negative 1? Well, sine, if you remember what a sine wave looks like, that It's here. Well, where am I? Okay, sine is -1 at 3 pi over 2, 3 pi over 2, and that's it. And so what we have here are our solutions within, right, 0 to 2 pi. So for this one, I'm going to make that an arc, okay? Solve the equation. This is quadratic, but I do notice one thing, and that is this being quadratic. I'm going to set this equal to 0. I get 2 sine squared of x plus 5 cosine of x minus 4. I'm noticing that sine squared of x, and I've got cosine squared of x. So I have to get rid of one of those, because in order for me to factor this, I am going to have to have all the same sinusoids. So I'm going to get rid of that. Actually, I'm going to rewrite this. Let's see, I'm thinking of something. 2 sine squared of x minus 4. Let's see if this will work. Cosine of x. I'm going to factor out a 2. And then I have sine squared of x minus 2. That didn't get me anywhere. So I'm going to erase that. So what I'm going to do is go back to my original thought and for this problem. And I'm going to change this sine squared of theta and make that, because this is what I'm going to do. Sine squared of x plus cosine squared of x is equal to 1. So I want this sine squared to be gone. So I'm going to replace that with 1 minus cosine squared of x. And so in doing that, I'm going to have 0 equals 2 times 1 minus cosine squared of x plus 5 times cosine of x, and then minus 4. Now I'm going to distribute. I get 0 equals 2 minus 2 cosine squared of x plus 5 cosine of x minus 4. I notice that I can say 2 minus 4. So I'm going to have theta equals negative 2 cosine squared of x plus 5 cosine of x minus 2. And for the sake of just having my first term positive, I'm going to divide everything by negative 1. And so now I have 2 cosine squared of x minus 5 cosine of x plus 2. I'm going to factor, and factoring this, I'm going to have 2 cosine of x times 1 cosine of x is going to give me 2 cosine squared of x. My signs are going to see my plus here with the minus are going to be a negative and a negative. I'm going to have a 2 here, a 1 here. This is very similar to another problem that we did. Because now we're multiplying and we've got -4 and -1 is -5, we're going to split this up and we're going to go cosine of x minus 2 equals 0. This might be the same problem we did before. We already know this one is not happening because when is cosine 2? It's not. So this one is a no solution. This one, we get 2 cosine of x minus 1 equals 0. So 2 cosine of x equals 1. Cosine of x equals 1/2. So x equals arc cosine of 1/2. And this is asking me, where is cosine 1/2? And we've done this one from 0 to 2 pi a couple of times actually already. Cosine is positive in this quadrant and also in this quadrant here. So from here to here, adjacent over hypotenuse, this is root 3. This is a 60-degree reference. So x is equal to pi over 3 and also 1 and 2/3. So 1 and 2/3 is 5 pi over 3. And actually, those are the only answers I have that are in between 0 and 2 pi. So this problem, this is the same problem. Okay, so moving to the next problem. What we have here is 2 cosine x plus sine of 2x equals 0. So for this problem, I would probably change this to the double angle to 2 sine x cosine x equals 0. And I would factor out a 2, and I would factor out a cosine of x. And I would get a 1 plus sine of x is equal to 0. I would split this up, and I would get 2 cosine of x equals 0. Divide by 2. Cosine of x is equal to 0. X is equal to arc cosine of 0. And this will be sine of x is equal to negative 1. X equals, move the sign over, arc sine of negative 1. And so we have two answers. We're saying, okay, where is cosine 0? So I'm looking at my cosine graph that does this, right? It's 0 at pi over 2 and at this value, which is 3 pi over 2. What did I do wrong? This is 2 pi. This is pi. So this is 1.5, right? Which is 3 pi over 2. I said that. Okay. And then we also have, and this didn't ask me for anything. So I guess I'm just going to say this is going to be solved for all solutions. This is saying, where is sine negative 1? Sine is negative 1 here. Okay. And so that's going to be also at 3 pi over 2, which I already said here. So we're going to solve for all solutions. So it'll be pi over 2 plus or minus 2 pi n. And we're going to get 3 pi over 2 plus or minus 2 pi over n. And I'm just going to make a note, solve for all solutions. Okay. And lastly, I really like this problem. The reason that I really like this problem is because a lot of people will think that you're going to have to divide by, they're going to want to divide by sine. And most importantly, you need to know that you don't divide by sine, because if you were dividing by sine, you would actually lose an answer. And so my example for this would be something like this. It'd be akin to this. If I had x squared is equal to, let's say, 3x, okay? And you made the mistake of dividing by x, right? And you got x equals 3, and you're like, oh, so happy because we got 3 as an answer. But by dividing out a variable, you've lost an answer. See, this is quadratic. And that being quadratic, that means you have two solutions, okay? And what should have happened was never divide out one of your variables. When you see something as quadratic, the best thing to do is to say, oh, it's quadratic. I need to set it equal to 0. Because once you do that, and once you get in the habit of saying, oh, it's quadratic, I need to set it equal to 0, then you will move this 3 over to the other side. You'll get 0 here. And then you'll be like, oh, I need to factor out an x. Or you could use the quadratic formula, completely fine, minus 3. And then you would split this up, and you would get x minus 3 equals 0, x equals 3, x equals 0. And notice that I actually have two solutions because it is quadratic. And so in doing this problem right here, if I divided out that sign, I am going to lose one of my answers. And so keep that in mind. And that's kind of an important thing. I'll show you when it's all said and done. Let's work this out. So we're going to go tangent of square root of x times sine of x minus sine of x is equal to 0. I'm going to factor out a sine of x, and I'm going to get tangent square root of x minus 1 is equal to 0. I'm going to split these up, and in doing that, I get sine of x is equal to 0, and tangent square root of x minus 1 equals 0, so that equals 1. Here, I get x equals arc sine of 0. Here, I get, here I need to square root both sides, right? And so I get tangent of x is equal to plus or minus 1, which means that x is equal to arctangent of 1, and our x equals arctangent of negative 1. And in doing this, this is asking me, where is sine 0? Well, sine is 0. Remember a sine wave? Here, here, and here. So it's 0 in 3 different places. And they didn't give me any kind of restrictions here. So I'm actually going to make this from 0 to 2 pi, not inclusive. So here, x is going to equal 0 and then pi. Okay? And then here for this value, and then because I'm only restricting it to values less than 2 pi, but greater than 0. For this one, where is tangent 1? So for this one, I'm going to say, well, all students take calculus. Tangent is positive 1 over 1, right? Root 2, where am I? I'm at a 45-degree reference, or pi over 4. So this value right here is going to be pi over 4. So this is x equals pi over 4. And this value here, oh, but I guess I am also 1 students down here, which is 1 1/4. So 1 1/4, which is 5 pi over 4. Okay, so far I have 2 answers here. I have 2 answers here. And now I got to find tangent. Where's tangent negative 1? Well, it's negative 1 in the second quadrant. And in the second quadrant, that would be 3 pi over 4. And it's also negative 1 in the fourth quadrant, which is 1 3/4. 1 3/4, which is 7/4. Okay, so all of my answers together that are between 0 and 2 pi would be 0, and I'm not going to put these in order, but you can. Pi over 4. We have 5 pi over 4. We have 3 pi over 4. And we have 7 pi over 4. So these are all my answers, okay? Remember in the very beginning what my question was what if we had divided out that sign? If we had divided out that sign, right? Divide, I would have just had tangent squared of x is equal to 1. And I would have only had this side. So I would have had 4 answers, but these 2 answers here would not have existed had I done that. So just be careful and just be cognizant of that you can't divide out values with your quadratics. So that's it. I hope that helped. And thanks for watching. All right, bye.